Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about periodicity of elements, lecture 1, unit 2, CC1 paper or minor 1 paper. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about periodicity of elements, S, P, D, F block elements, the long form of periodic table. So let's talk about the long form of periodic table, that is the extended periodic table. So usually what happens, different elements have been discovered by different scientists. So in 1861, the Mendeleev attempted to classify elements in some order that could explain their properties. So that gave rise to the periodic law. So the periodic law says the physical and chemical properties of elements are a periodic function of their atomic weights. So Mendeleev arranged all the elements in the increasing order of their atomic weights in the form of a table known as Mendeleev's periodic table. So there are some anomaly or drawbacks in Mendeleev's periodic table. So there are three pairs of elements like tellurium and iodine, argon and potassium, nickel and cobalt. So these three pair of elements not in accordance with their chemical behavior. Similarly, rare earths and their isotopes also have some problem. So that gave rise to the new concept that is called modern periodic law by Moseley in 1911. So the modern periodic law says the physical and chemical properties of elements are a periodic function of their atomic number. So now all elements are arranged on the basis of modern periodic law and it is called the long form of periodic table. So mechanically this periodic table is the extended form of original Mendeleev's table named as extended form of periodic table. So here is the rough sketch of a long form of periodic table. So at the extreme left hand side of the periodic table, that is S block elements 1A and 2A, and from 3B to 2B. So this is the middle one, those are called transition elements or D block elements, and at the extreme right hand side there are non-metals and metalloids, those are called, and noble gases, zero group elements, so those are called P block elements. And at the bottom of the periodic table you will find lanthanides and actinides, those are called A block elements. So this is the brief history of a periodic table. So at the extreme left side, S block element, that is alkali and alkaline earth metal. At the middle you will find D block element or transition elements, and at the extreme right hand side you will find the P block elements, and at the bottom of the periodic table you find A block elements where you have lanthanides and actinides. So here is the modern periodic table. So here atomic number 1 starts from hydrogen and it ends here it is with 112 Cn, copernicium. So till now 118 elements have been discovered. So this group is called alkali metals, and this is alkaline earth metals, and from scandium to zinc. So this middle one, that is called D block elements, and this extreme right side boron to fluorine and neon. So this is called P block element, and at the bottom of this you have lanthanides and actinides. So as you can see, there are 18 vertical columns, those are called groups. So this periodic table contains 18 groups, and if you count the horizontal rows, there are 7 horizontal rows, those are called periods. So it contains 7 periods and 18 groups. So let's talk about some features of a long form of periodic table. So for group 1A and 2A, the outermost configuration is NS1 and NS2. So those are called alkali and alkaline earth metal. So this group and this group, these are called alkali and alkaline earth metal. So group 1A and 2A. Similarly, IB to VIB and VIA, those are called D block elements or transition elements. So first transition series starts from scandium to zinc. Similarly, second transition series from yttrium to cadmium. Third transition series lanthanum to hafnium and up to mercury. And fourth transition series starts from actinium and it ends with 118, that is 6d series elements. Similarly, A block elements, those are called inner transition elements. So there are 4F elements are lanthanides from cerium to lutetium, and 5F elements are actinides, starts from thorium to lawrencium. And P block element contain metal, non-metal, noble gases, that is group 0, VIIA, called halogens. So there are 7 horizontal rows called periods, and there are 18 vertical columns called groups. The valence shell electronic configuration varies from ns1 to ns2, that is called s block element, and the elements with p orbital are being progressively filled, called p block elements. Exception is helium 1s2. The electron enters to the n-1 d orbital of the main shell are called d block elements, and the elements in which the extra electron enter to n-2 f orbital of the main shell are called a block elements. So let's find out some limitation or drawback of this long form of periodic table. So the position of hydrogen not solved completely. So hydrogen electronic configuration is 1s1. So this is alkali metal has also electronic configuration ns1. So their properties are not similar. Similarly, position of helium. So helium has electronic configuration 1s2. So rest of inert gas has also ns2 and np6 configuration. So the different place should be given to helium. And the position of lanthanide and actinide, the periodic table is unable to include these elements in its main body. And the periodic table does not reflect the exact distribution of electrons among all the elements. Please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. For class 11th and 12th students, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.